As we can see in the picture, it's a dynamic presentation of the difference between DC circuitry and AC circuitry. In the DC circuitry on the left, we have a battery. It has a plus side and minus side, positive and negative, and the current, it goes only in one direction, non-stop in a closed loop. AC, on the right-hand side, we can actually see by the symbol of the generator as an AC generator, we see a sine, and we will deal a lot with this sine wave in this course. But this AC sine generator generates current in two directions. Half of the time it will go one direction, and half of the time it will go the other direction. This is why it's alternate. 50% of the time goes to one single direction, as opposed to DC, which is direct, one direction only. Now let's try to analyze, kind of top level, how to generate alternate current, how we actually generate this sine wave. And let's look at the movie. What do we see here? We see a magnet. It has a north and a south, like every magnet has. And because it has north and south, there is a magnetic field running between the north and the side. And there is a coil that rotates within this flux, within this electromagnetic field. Because, and no matter how we do it now, we will know it later, but because there is a rotating coil in between the lines of the electromagnetic field, current is being generated. This current goes through a meter. And because the coil rotates, the current in each end of the coil is in different direction. So as the coil rotates and one particular side of the coil stands, current is being generated in one particular direction, goes to the meter. Now, as the coil continues to rotate, the other half, the other arm of the coil, stand in within this flux electromagnetic field, current will go in the other direction. So we actually can see the needle of the meter that goes from one side to the other side, alternate the directions. And when the rotation is exactly identical in each degree of the 360 degrees, we have a circular rotation, we get a sine wave. So if we look carefully, we will see the direction of the current on the red wires, and we will see the progress of the sine wave as it's being generated. So just to summarize in top level really, the way we generate alternate current is by rotating, circular rotation, a coil in between, within an electromagnetic field, creating a current. This current is half of the time in direction number one, half of the time is in the opposite direction, and this is the alternate current.